Hello, I'm Haiying. Welcome to Feature Extraction and Feature Engineering. In this video, we'll discuss the data cleaning process. The omission of data cleaning steps in analysis can lead to misleading results for decision making or a dangerous impact on students or users. We'll discuss the specific actions we usually take when we receive a dataset. We'll typically check data quality, workflow, inspection, cleaning, and verification. In this module, we'll focus on data quality, particularly for numerical and categorical data. Data quality is defined as a data's suitability for a user's defined purpose. It is subjective, as the concept of quality is relative to the standards defined by the end user's expectations. Here are 10 dimensions of data quality that we examine when receiving a dataset. In this class, our emphasis will be on data validity. For more detailed exploration of other dimensions, you can refer to Wikipedia or the ICE-DQ webpage for comprehensive information. High-quality data should meet specific criteria. These criteria include data type constraints, set membership constraints, range constraints, mandatory constraints, unique constraints, regular expression patterns, and cross-field validation. When discussing data types, we are referring to both qualitative and quantitative variables. Qualitative data is also called categorical data, providing information based on specific qualities or characteristics rather than quantities. There are two main types of qualitative data: nominal without specific order or hierarchy, such as nationality, and ordinal with an order or a rank, such as letter grade A and B. Quantitative data is characterized by measurable quantities represented by numerical values. There are two main types of quantitative data: continuous data, such as students' height, which includes decimal values, and discrete data, such as the number of male students, which can be counted with a whole number. We will use a dataset to illustrate how to check data validity. Data type constraints. Values in each column should follow the same data type, whether it be numeric, date, Boolean, etc. The science score should be numeric. However, there is a text expression for score. We should replace it with a numeric value of 18 to keep the data in the same type. Gender should be Boolean, either using female and male or 1 and 0, but not mixed using both. So we can change 1 to female and 0 to male based on the data codebook. Gender should be categorized as either female or male, but the dataset contains a value of teacher. This is incorrect. It is impossible for us to verify this data value, so we can replace it with a missing value. Thus, the gender variable also involves a data completeness issue. This phenomenon implies that each column may contain multiple types of issues that require cleaning. You can address all the issues on a column-by-column basis. First date is mixed with different types of date format. I would like to do some computations in the future, such as to update the age. Therefore, I change it to the same date format: year, month, and day. First date and gender variables involves both data type issues and data inconsistency issues. Range constraints. Values should fall within a certain range, such as months between 1 and 12. Cross-field validation means that certain conditions should be satisfied. In the age column, there is a value of 98. This is likely incorrect for a dataset representing undergraduate students. Given that it is uncommon for individuals to attend schools at the age of 98, I reviewed the birth date column and found that this person was born in 1955. Consequently, the correct age should be 68, not 98. Similarly, the variable trial has a value of 99, which is inaccurate for a maximum of 3 trials. Additionally, the science score has a value of 999. While it's common to use 99 or 999 to indicate missing values, these scores should be used to replace missing values. I choose to leave them blank. This choice is intentional because I plan to use imputation methods to handle missing values in the dataset. Another reason is the presence of a blank to represent a missing value in the false row. This indicates an inconsistency in the data type format. You may delete these observations if you prefer to use the complete dataset. Alternatively, you can choose both methods to compare the effects of removing the missing values with those of using imputation methods. Mandatory constraints mean that specific fields cannot be left empty. For example, unique ID is used to match different datasets and shouldn't be left blank. In this dataset, the only option for matching with other datasets are the birth date and the ID columns, or recollecting students' unique ID, which is always challenging. Unique constraints require the value to be unique across the dataset. In this dataset, ID 2 occurs twice. One of these IDs must be wrong. After checking other variables, we could not find relevant information to validate this ID. Therefore, we need to remove this observation if we will use ID to match with other datasets. Or we can assign it with a new ID number if this dataset is the sole source for the analysis. Use pandas, NumPy, matplotlib, and Seaborn libraries for exploratory data analysis to check and ensure data quality. Here is a Python cheat sheet containing commonly used codes for exploratory data analysis. Please feel free to add more for your future reference. Thank you for watching this video.